Welcome to our comprehensive guide on private water systems. Today, we are going to explore everything from the basic components that make up a system to how we calculate pressure and size the equipment, and finally, how to maintain and troubleshoot these systems effectively. A private water system relies on a team of components working together to deliver drinking water efficiently. The main players include an electric motorized pump, a pressure tank, air volume controls, pressure switches, safety relief valves, and a foot valve. Let us look at what each of these does. The pump is the heart of the system, pushing water from the well into the house. But if the pump turned on every time you opened a faucet, it would wear out quickly. That is where the pressure tank comes in. It uses compressed air as a stored energy source. When the pump pushes water into the tank, it compresses the air. This compressed air then pushes water through your pipes on demand, allowing the pump to rest until the pressure drops. Over time, water can absorb the air inside a standard tank, causing it to become waterlogged. To prevent this, we use air volume controls. A float-type control opens a valve to pull in outside air when the water level gets too high. A diaphragm type uses the negative pressure from the pump's suction to draw in a small amount of air, pushing it into the tank when the pump shuts off. How does the pump know when to turn on and off? That is the job of the pressure switch. It uses a flexible diaphragm connected to the plumbing. As pressure builds, it pushes against a spring and breaks the electrical circuit, stopping the pump. When pressure drops, the spring pushes back, reconnecting the power. For safety, a pressure relief valve is also installed to release water if the switch fails, and pressure builds to dangerous levels. Down at the bottom of the well, on the suction piping, we have the foot valve. This is a type of check valve that only lets water flow up. When the pump shuts off, the foot valve closes, keeping the pipe full of water. This maintains the pump's prime, which is especially critical for centrifugal pumps that cannot pump air. To select the right pump, we need to understand head, pressure, and friction loss. Head is pressure expressed as the height of a water column. Interestingly, a column of water 2.31 feet high exerts exactly 1 pound per square inch of pressure. Friction loss is the reduction in pressure caused by water rubbing against the inside of the pipes. When sizing a pump, we calculate the total head. This is the sum of the vertical lift from the well to the pump, the friction loss in the suction pipe, the vertical lift from the pump to the house fixtures, the friction loss in the discharge piping, and the desired usable pressure at the faucet. By converting all these factors into feet of head or PSI, we can choose a pump powerful enough for the job. While older tanks let air and water mix, modern tanks separate them to prevent waterlogging. A floating disc tank uses a simple neoprene wafer floating on the water. A diaphragm tank has a permanent, flexible separator locked inside. A bladder tank holds all the water inside a synthetic rubber bag, which is great for corrosive water because the water never actually touches the metal tank walls. Sometimes you do not even need a traditional pressure tank. An elastic cell can be installed in the well or at the point of use, acting like a miniature expansion tank to jumpstart pressure. Another option is a pump controller, like a mass control, which replaces both the tank and the pressure switch. It simply turns the pump on whenever there's a demand, providing a constant, steady pressure. Sizing a system depends on peak demand, usually measured in gallons per minute based on the number of fixtures in the home. Electrically, it is highly recommended to wire pumps for 240 volts instead of 120 volts if possible. At 240 volts, the current is cut in half, which allows the motor to run cooler, requires smaller wire, and prevents your house lights from dimming when the pump starts. What if your well produces water very slowly? If the well's yield is less than your family's peak demand, a two-pump system is the solution. A low-yield well pump slowly fills a large, unpressurized storage cistern. Then, a second pump draws from that cistern to pressurize the house. This ensures you always have a reserve of water ready for peak usage times, like morning showers. Proper installation location is vital for maintenance. Components must be protected from freezing, direct sunlight, and stagnant air. The well itself must be sealed properly at the surface to prevent contaminated runoff from entering the aquifer. A pitless adapter is often used to route the water line into the house below the frost line, keeping the system safe from winter temperatures. Even the best systems need maintenance. If you experience reduced water yield, it could be aquifer depletion or mineral scale plugging the well screen. Sediment suddenly appearing in your water often points to a corroded casing or a failed well seal. And if your faucets are spurting air or milky water, you might have dissolved gases like carbon dioxide or methane in the well, or a failing pump prime. To wrap up, a private water system is a carefully balanced network. By understanding how the pump, pressure tank, and controls interact, how to calculate head and pressure, and how to properly size and protect the equipment, you can ensure a reliable and safe water supply for any home. Thank you for joining this lecture.